Hello, and welcome. Today I will be explaining the code used to collect DHT data and display it on the Adafruit IoT dashboard by using a ESP8266 node MCU. Hashtag include simpledht.h. Hashtag include ESP8266 Wi-Fi.h. Hashtag include Adafruit_MQTT.h. Hashtag include Adafruit_MQTT_client.h. These lines include necessary libraries for your Arduino project. Libraries are collections of pre-written code that provide functions and features to make development easier. In your code is included to use the simpledht library, which helps interface with the DHT11 sensor. Is included for using functions and features related to the ESP8266 Wi-Fi module. This library enables your device to connect to a Wi-Fi network. Adafruit_MQTT.h and Adafruit_MQTT_client.h are included for MQTT communication with Adafruit IO, a cloud service. These libraries provide functions and tools to create an MQTT client and send/receive data via MQTT. Hashtag define WLAN_SSID. Hashtag define WLAN_pass. These lines define constants for your Wi-Fi network's SSID and password. Constants are like variables, but their values cannot be changed during the program's execution. In your code, WLAN_SSID is a constant that holds the SSID, Wi-Fi network name, for your network. WLAN_pass is a constant that holds the password for your Wi-Fi network. These credentials are used to connect your ESP8266 to the specified Wi-Fi network. Hashtag define AIO_server, io.adafruit.com. Hashtag define AIO_server port 1883. Hashtag define AIO_username, testis13. Hashtag define AIO_key. These lines define constants for Adafruit IO server and your account details. In your code, AIO_server is a constant that holds the address of the Adafruit IO MQTT server. AIO_server port is a constant that specifies the MQTT server's port. 1883 is the default for MQTT. AIO_username is a constant that contains your Adafruit IO account username. AIO_key is a constant that contains a unique key associated with your Adafruit IO account, used for authentication. This key ensures that only you can access your Adafruit IO account and send/receive data. Wi-Fi client. This line creates a Wi-Fi client object named client. A client object is essential for establishing and managing connections over Wi-Fi. In your code, it's used to connect to your Wi-Fi network and later for creating an MQTT client to connect to Adafruit IO. Adafruit_MQTT_client MQTT, and client, AIO_server, AIO_server port, AIO_username, AIO_key. Here, you create an MQTT client object named MQTT. An MQTT client is a piece of software that connects to an MQTT server, in this case, Adafruit IO, to exchange data. In your code, and client is passed as the first argument. It means your MQTT client will use the Wi-Fi client, created above, for network communication. AIO_server and AIO_server port are used to specify the MQTT server's address and port. AIO_username and AIO_key are your Adafruit IO account details used for authentication. This MQTT client is how your ESP8266 will communicate with Adafruit IO. Adafruit_MQTT_publish temperature equals Adafruit_MQTT_publish, and MQTT, AIO_username, /feed/temperature, Adafruit_MQTT_publish humidity equals Adafruit_MQTT_publish, and MQTT, AIO_username, /feed/humidity. These lines create two MQTT publish objects, temperature and humidity. MQTT publish objects are used to send data to specific topics, feeds, on the MQTT server. In your code, and MQTT is passed as the second argument when creating these objects. This associates them with the MQTT client you defined earlier. AIO_username, /feed/temperature, and AIO_username, /feeds/humidity specify the MQTT topics, feeds, to which the data will be published. These feeds are unique to your Adafruit IO account and are named temperature and humidity. Int pin DHT11 equals 0, simple DHT11 DHT11, pin DHT11, byte hum equals 0, / stores humidity value byte temp equals 0, / stores temperature value. These lines set up the DHT11 sensor and declare variables to store sensor data. In your code, pin DHT11 is an integer that specifies the pin to which the DHT11 sensor is connected, pin 0 in this case. Simple DHT11 is a library-specific class used to interact with the DHT11 sensor. It's named DHT11, and the constructor initializes it to work with the specified pin. Hum and temp are variables of type byte, which can store values from 0 to 255, used to store humidity and temperature values read from the DHT11 sensor. Void setup. In the setup function, you perform the setup and initialization for your Arduino. Here's what each line does. Serial.begin 115200. This line initializes the serial communication with a baud rate of 115,200. It's used for debugging and printing messages to the serial monitor. Serial.println f Adafruit IO example. This line prints Adafruit IO example to the serial monitor, indicating the start of your program. Delay 10. This introduces a small delay, 10 milliseconds, for stability. Serial.print f connecting to. This line indicates that the program is attempting to connect to a network. Serial.println WLAN_SSID. It prints the SSID, Wi-Fi network name, to the serial monitor. Wi-Fi.begin WLAN_SSID, WLAN_pass. This line initiates the connection to the Wi-Fi network using the SSID and password you provided. The while loop checks the status of the Wi-Fi connection with Wi-Fi.status. It repeatedly prints dots to the serial monitor while waiting for a successful connection. Once the Wi-Fi connection is established, it prints Wi-Fi connected and your device's IP address to the serial monitor. Finally, it calls the connect function to establish the MQTT connection to Adafruit IO. Void connect. The connect function is responsible for connecting to Adafruit IO via MQTT. Here's a detailed breakdown. Serial.print f connecting to Adafruit IO. This line notifies the user that the program is attempting to connect to Adafruit IO. int8_t_ret declares an integer variable ret to store the return code of the MQTT.connect function. The while loop attempts to connect to Adafruit IO using the MQTT.connect function. The return value is stored in ret, and the loop continues until the connection is successful, ret equals 0. Inside the loop, there's a switch statement that handles different return codes, error conditions, and provides error messages to the serial monitor. Common error codes include wrong protocol, ID rejected, server unavailability, bad user/pass, not authenticated, and failed to subscribe. If ret is greater than or equal to 0, indicating a problem with the MQTT connection, the MQTT.disconnect function is called to disconnect from Adafruit IO. After handling the error, it prints retrying connection to the serial monitor and delays for 10 seconds before attempting to reconnect. Once the while loop exits, meaning a successful connection is established, it prints Adafruit IO connected to the serial monitor. This setup function prepares your Arduino by initializing the serial monitor, connecting to Wi-Fi, and establishing an MQTT connection to Adafruit IO. It sets the stage for data publishing in the loop function. Void loop. The loop function is the main execution loop that runs continuously. Here's what each part of this function does. If MQTT.ping 3, this checks if the MQTT connection to Adafruit IO is still active by sending a ping. If there's no response after 3 attempts, it means the connection has dropped. In this case, it proceeds to reconnect by calling the connect function. DHT11.read and temp and hum null. This line reads temperature and humidity data from the DHT11 sensor and stores the values in the temp and hum variables. Serial.print int temp serial.print *c. This line prints the temperature in degrees Celsius to the serial monitor. Serial.print int hum serial.println h. This line prints the humidity level to the serial monitor, followed by a line break. Delay 5000. This adds a delay of 5 seconds, 5000 milliseconds, before moving on to the next part of the loop. This delay controls how often data is read from the sensor and published. If temperature.publish temp, this line attempts to publish the temperature data to Adafruit IO. If the publish operation fails, it prints failed to the serial monitor. If humidity.publish, this line attempts to publish the humidity data to Adafruit.io. If the publish operation fails, it prints failed to the serial monitor. If both publish operations are successful, it prints sent to the serial monitor to indicate that the data was successfully sent to Adafruit.io. In summary, the loop function continuously monitors the MQTT connection, reads data from the DHT11 sensor, prints that data to the serial monitor, and publishes the temperature and humidity values to Adafruit.io. If the MQTT connection is lost, it automatically reconnects. The delay ensures that data is read and published at regular intervals. Thanks for watching.